Hello, are we live?
Hi, everyone.
Hi guys, welcome to the live stream. My name is Günay, and today we have a special guest. Kevin is a software developer based in Munich, Germany, and today is going to tell us all about iOS, about being a iOS developer in Germany, and he also has a YouTube channel. I think you guys should check it out. We'll leave the link in the comment section, I guess. And before further ado, I'm leaving the stage to Kevin. Hi, Kevin. Welcome.
Hi, Gunnar. Thank you for having me. I'm very happy to be part of this little live stream. And as Gunnar already introduced, I will just share my screen and we jump right in because today we are talking a bit about iOS development. So can you see my screen? Probably has to switch. Okay, here we go. Okay, yes, as we already said, we are talking about iOS development. Gunnar already told you that I'm running a YouTube channel, and there I'm talking all about iOS development, software engineering in general. I also have a bunch of tutorials all about Swift and iOS development. It's not in English, it's in German. But if you want to learn some German and something about software engineering at the same time, you can check it out. But this is just a side project for me. It's a hobby. My actual job is being an iOS developer. I started 2012 with iOS 6 in university. And during my master studies, I started a job as a software quality assurance engineer, which means I was writing code to test software products. And I made the change 2015 to become a full-time iOS developer because I just enjoyed it so much. And I'm doing it ever since. Currently, I'm working at Viper TV, which is a platform for live streaming TV. It's also German only, but the application is fully native. So we are working on fully Swift and native iOS code. Of course, there are some other options out there like Flutter, React Native, and of course, there are a lot of benefits like you're writing code once and you can run it on iOS, Android at the same time. But there are still reasons why to run native. And some of the reasons are usually you get better performance just because there's no additional abstraction layer in between. It's more secure because you have also like less layers in between, so there's less surface for attacks, and you have direct access to things like the secure enclave of iOS or of the iPhone itself. It's more interactive and more intuitive, also because animations and stuff are usually perform better because there's again less abstraction in between, and you have the full feature set of iOS devices or iPad devices. As I already said, it's about iOS development, but this is like the main thing that most people think about it. But there are actually more things you can write code with. For example, on the iPad with iPadOS, tvOS, which is another platform, you can also use all your Swift skills to write apps for that, watchOS for your Apple Watch, and of course, macOS. There is also another thing, but I will talk about it in the end. So let's go into the programming language Swift. This is the main language. As you see in the lower corner, it's also Objective-C, so you can choose when you write an iOS application if you want to write it in Swift or in Objective-C. And we are continuing only with Swift because this is much easier and it's much more fun to work with. Objective-C got used all the time, but in 2014, Apple introduced Swift 1.0. And 1 year later at the WWDC, they announced that it's going to be open source, which was a huge thing because Apple usually doesn't do that. But this opened the door for also other platforms, for example, Linux, because you can write also Swift code on Linux. But as I said, more on that later. It's an alternative for Objective-C. It's not a fully replacement. It also lives side by side. So you can have an existing Objective-C project and run Swift code at the same time and compile everything in the same application. So it's living side by side. And today we are already running Swift 5.5.1. So in the past 6 years, there's a lot of development going on. And in order to write iOS applications, you need Xcode. And here's a little bit of a limitation. Xcode is so that it's the only option for you to write your own iOS applications. And Xcode only runs on macOS. So there's no way to build iOS applications if you're not using a Mac. For a lot of people, that's a deal breaker because, of course, especially for students, Macs are really expensive. Also, testing devices are really expensive because if you want to develop an app and you can use the simulator, of course, but there are a lot of things like camera, for example, or the fingerprint reader, stuff like that, or Face ID, which doesn't exist in the simulator. So you need a real device. So that's like a big deal breaker for a lot of people. But in case you are already having a MacBook and running macOS, you can build apps very easily in Swift. And I would say that we will jump into a Swift playground. More than that, I will tell you what it actually is. So a playground is something that helps you to build apps or test code without having the entire thing around the application. So it's like, as the name says, it's a playground. So we can stand with an iOS playground blank. We can just make it, I don't know, like a demo. And the playground actually looks like that. So we make that full screen. And it's fully interactive. We can import here, let's say, Foundation, which is like everything that Swift delivers. And it already has here a string. Swift is using type inference. So for example, here we have a variable called greeting, and we assign the value hello playground. And we don't need to specify that that's a string because we are using here a string literal, and Swift understands that this is a string. So if we do Option key and press, we see that greeting has the type string. Maybe I can make that a little bit bigger. It means that, of course, if we want to make it very explicit, we can say that this must be a string, which is in the end the same thing, but it's a bit more explicit. This is how we declare a variable, so something that we can change. So for example, we have this greeting now, and we can just assign, because it's a variable, another value to it. And now greeting, it has the value hi. We can also let it run. Oops. Okay. It's compiling, and I think should be running. Exactly. So it's fully interactive. So we always see the actual value here on the right side. And down here, we have the console. So for example, if we want to print something in the console, we can also say, okay, just print greeting, and it should appear here in the console. And we can assign different values to it. For example, with the equal symbol here, and say hi, and our new value is hi. If we don't want to make it mutable, greetings, we can also use a constant, and this is declarable with let. You would see now that it's not possible. Usually the compiler should give us an error now because you can't assign another value to greeting because greeting is a constant. So the compiler already suggests here, change let to var to make it mutable. We don't want to do that now. We can just continue with some other types. Of course, you can also use, I don't know, like numbers and assign 3. By default, that's an integer, but of course we can also make it double or like a floating point number by using the floating point to make it more explicit. So we can do a lot of stuff here. Let's start with classes. Classes, you can also just there by class, by using class. And we can give it a parameter or a property called name, for example, of that person. And we say that this is a string. Now we also need to have an initializer. The initializer, because when we want to create an instance of person, we just pass our value, and we make here self name. Self name is the one of the person, and by using name here, this is the name that we pass here as an argument into the initializer, and we assign it to self, and our objects can be initialized. There's a different way to create instances, and this is using structs. And that's a very important thing in Swift or in iOS development in general. We have the differentiation between value types and reference types. So let's say we have here a struct, which is a value type. They are passed by value. What that means I can tell you in a second. So we have here a book, we call it title. And the funny thing is, in compiler actually creates this initializer without writing us down. So we can just create now an instance of book, let's say book 1, and we create an instance of it by opening it and, I don't know, giving a title like Harry Potter. And let's create another instance of this struct, so we can talk about the differentiation between reference types and class and value types. As I said, structs are value types, which means they are passed by value, which means when we assign now, when we create a new instance, and we say here, let's make this a var so we can change it later, and we have here book 2, and we assign book 1. And what actually happens here is we take our book 1 and we copy the value of book 1 into book 2. So when we print now the book 2 title, we should have here also Harry Potter. And now what we can do is, when we say book 1, we want to print the title of book 1. We should have here Harry Potter, because this is Harry Potter of book 1 and Harry Potter of book 2. But after we we basically copy book 1 into copy 2, we can change the value of book 1, the title. For example, I don't know, Lord of the Rings. And when we print it now, okay, 1 second. This must be a var, because otherwise we can't change it. We see here that book 1 has the title Lord of the Rings, and book 2 has Harry Potter. And that's what I mean with it basically passes the value. So when after the assignment of book 1 to book 2, we change the value, but this doesn't change the value of book 2, only of book 1. Whereas, let's make it remove the person, and let's change it to make it a class. We're doing exactly the same thing now. Not its title. Just the difference is that we're using a class, and this is passing the reference. So basically what we are doing here, we are creating an instance of book 1, and we are creating another instance, or basically another variable called book 2, and we assign not the value, but the reference to it, which means that book 1 and book 2, they point to the same memory location. So when I change the value of one of these, it changes basically for both, because it changes where this value is located. So when I run it now, both should print Lord of the Rings. I hope that makes sense. There are a lot of benefits and also disadvantages for it, because when you pass a value by copying it, like with a struct, for example, and value types are, for example, also strings, integers, floating numbers, like all of these types, they are all value types, but you can create your own ones by using structs. It has the benefit, of course, that you are that you don't have like unwanted side effects. So if you change the value of one thing, but you don't want to change it in the other thing after copying it, then you have to use structs. But this is basically how it works, like very briefly. So I would say that we don't waste much time, and we are building now very quickly an iOS application, which looks like that. 1 second. By creating a new iOS app by 1 second, project. Here we go. So when we open Xcode and we make file new, we click here on project, and we can choose here if we want to have an iOS app, macOS, watchOS, tvOS, or whatever other thing. Driver kit, I think that's for CarPlay, but I'm not 100% sure. I've never worked on that. And you can also choose if you want to play a game, AR applications, or some other stuff, but we want to have a basic app. We call it now, I don't know, Fruits. And here we have now the differentiation. So let's say we use here the interface storyboard. We have basically two frameworks in iOS to build applications, like or the user interface of it. And that's one is UIKit, which is the first one, which exists since many years. This is when you have to use or choose storyboards. And a few years ago, Apple introduced Swift UI, which is a complete different approach in creating UI. I think for learning, and if you don't want to work like as a full-time iOS developer, it makes sense to learn Swift UI because it's a bit more fun, it's a bit more interactive. But if you really want to work as an iOS developer, I suggest you to first start with UIKit, so storyboard, because all existing applications of like which are a few years old, they all use UIKit. So in case you want to work somewhere, it's very likely that you don't start working on a Swift UI project. There might be some Swift UI code already. For example, the widgets on the iOS home screen, they are usually written, or they must be written in Swift UI, but everything else is usually in UIKit. When you use storyboards, you can also choose the programming language, Swift or Objective-C. Here, I highly suggest you to use, recommend you to use Swift. But as I said, we are using now Swift UI. Here, of course, you can't choose it because Swift UI only exists for Swift. So let's make our first app. We don't want to replace it. Let's make it Fruits app, for example. Okay, that's it. Maybe I have too many projects already in my downloads folder. Let's do it again. App, Fruits. Okay. For some reason, I don't get the pop-up. Let's just quit that for a second. Open Xcode again. And we create here a new project. It's an app, but Fruits, Swift UI. Okay, here we go. And we are opening that on the desktop. We can run it in full screen. And here we are using Xcode with everything what we need to build iOS apps. Xcode is the IDE, so the integrated development environment. And as you can see here in Swift UI, we have two views. Here we have our code. This is our view code. And here we have a preview of what our app will look like. And that's a nice thing because in Swift UI, we have hot reload. So we can basically run a simulator here. And basically what we are writing here, or how we are designing and writing the code for our UI, it automatically updates here on the other side. So we can change this one, for example, to hello Xcode, and you can see here, it automatically renders everything. And what we are building now is a very simple application to, One second. A very simple application to show some fruits in a list. So what we need for that is following. We want to have like a screen where we have a list of all the items. Then we need to define how an item looks like. And we want to have a detailed screen to see the fruit as a picture and like a little bit bigger after you tap an element in that list. So what we can start with is so just to briefly recap here, this is the starting point of our application. So we have our fruits app, and this has a body, which is a window. This body is in this case, a scene, but for the other screens, it's a view. And basically here we are just hosting in our window, like this is the container where we show all content of our application. We show this content view, and this is our content view. Our content view will change later to be a list, but let's start first with creating one of these cells. So we can call this one a fruit cell. And our fruit cell needs first, well, let's run it here so we can see fully interactive what we are building here. We can first create here as a title. And if you see here, we have two structs. We have first our structs of the view, and then we have the struct of our preview. In our preview, we are basically just initializing an example of what we are having here. And this is basically what will be rendered here in our simulator. As you see, we already get now an error because we added a new property called title. So we need to pass this value to our fruit cell. So let's say this is, and here our text will be not a fixed hard-coded text, but we are just using the title. When we run it, we should see that we are passing here apple. Now we want to create basically a text and right next to it an image. And this should be horizontally aligned because they should be right next to each other. So what we need here is an H stack, which means horizontal stack. And we want to have here our text inside. And we want to have an image. This image should have the same name as the title because we are loading them now in our assets. One second, we need some images here. I prepared them already. So let's just drag and drop them. So you can see we have here just some PNG image of apple, banana, lemon, mango, pineapple, and strawberry. So when we go back here to our fruit cell and we run it, we should, one second. We should make some adjustments because our image doesn't have, might be very big. So we want to make it resizable. Okay, now it appears. You see it's huge, but we want to have it smaller so we can give our image a frame. And we say it's just, I don't know, 50 by 50 points. And the alignment, we want to have that it's trailing. So that it's aligned to the end. Okay, it's a point. Zoom it. Okay. And our cell is now pretty small. So I would like to have a little bit of a distance. So what we can do, we can make a spacer view in between. So now it's aligned basically. We have here our label. We have a huge invisible spacer in between. And we have here our apple. That's not a problem right now because later we will host this cell this cell will be hosted into a list, and then it will look nice. Okay, and we can do cool things in Swift UI, like applying to that image here, for example, a shadow, and the shadow can have a radius of 10, and maybe you don't see it very well now, but there's a little shadow around the apple, which is pretty nice. So what we need is also a detail view. So let's create also one of that. Also, if you have any questions, just post them into the comment section. And when we are done, we will just go through them and we can answer them. We have our detailed view. Then our detail view, we need the same again. Let's just copy the entire thing, what we have here in our fruit cell with a few adjustments. So first of all, we don't want to have that the text is right next, so it should be like a title a little bit above and the image below. So what we can change here now is we don't want to have an H stack or horizontal stack, but a vertical stack. So all these elements are below each other. Okay, we need here again a property called title, because we pass later the value to that detail view, because we want to have one generic screen which can display basically any fruit. We can also remove the spacer here, and the compiler tells us that we need to pass an argument. Let's say on this one, banana. This is just to pre-render, it's a pre-show. So this is not actually the value that will be used later when we are running our app. So let's run that one to see. Okay, that's a little bit small, so we can use our text and give it a different font, for example, large title, for example. That's nice. We can also say, okay, it should be bold, so it's bold. And yeah, the text is all lowercase. So what we can do now is we can say text case, uppercase. So it's just big. And what else do we want to do? We can say, yeah, that image should be a bit bigger. Maybe we can see how big the image is. Okay, that's huge. Let's say the frame should be, I don't know, like 200 and also 200. Alignment we don't need. Okay, that looks already better. Okay, so we also have our detail view. And now what we want to do is we want to take the cell, list all the elements that we have. And when we tap on it, we go to our full screen banana. Let's go to our content screen. And let's create a list of all the fruits that we want to display. This data is now hard-coded, but imagine this could be also coming from an API, from some server. But of course, we don't have the time to build that now. So we just use some hard-coded array of fruits. So we have banana, apple, pineapple, mango, lemon, and strawberry. And we want to create a list. So we go again into our body. This is where all the content of this particular view exists. We have our list, and we can have our, see if that works. Okay, so as you can see, we have already one item in our list. But what we actually want to do is we want to have a lot of items. So what we can do here is we use for each, because this basically creates a loop for us. Our data are the fruits array. And we also need to give it an ID, so it understands that it should not, or understands that there are multiple elements. And we have our content. And here we can pass our individual fruit. And we can remove that. And for every, so basically what's happening here, we are looping over our fruit array. And we take every single of these fruits. And here we have every individual fruit, and we pass it to our fruit cell. Let's do that. We take our fruit. And as you can see, it already works. So we have our list of each of the elements. We pass, basically, we are creating for each element one cell, and we pass the string. And then it automatically renders everything. Now what we have to do is we need to build some navigation, because when we pass it, we want to go to another screen. So if we want to have that, everything needs to be in a navigation view. So we take a navigation view and we just move our list into that navigation view. Now we are able to push other screens on top of that one. So let's create in here, not directly the cell, but a navigation link. Here we have two things. We have the destination and the label. Our destination, our destination is our details view. And of course, here we pass also the fruit. And the label is our fruit cell. But this is what is happening here is that we have a navigation link and the label is what we display. And that's our little banana and apple cell. And the first one is our destination, which means what happens when I press on one of these cells? It basically pushes this details view on top of what exists. So we can also make it like fully interactive and running by clicking this little play button here. So we don't only render it, but now the app is basically in a simulator, as you can see. And it's fully scrollable because we have a list. We also need a title here. Let's say our list should have like a navigation title because that looks a little bit boring. We can call that one, I don't know, fruits. And as you can see here, we have already a navigation title. And if we scroll, you see it automatically goes into the navigation bar. Everything without any customization. It's really, really easy to play around with. And now when we click on one of the banana, we should see the full screen. And this was really easy. Like there's not much work to do to build like a very simple app like this, but you can see already like the way of customization and we can have here with very, very little effort is really amazing. And it's really fun to work with Swift UI. There's still a lot of things that are not working 100% like in UIKit, and there are still some limitations. But I think Apple is working really, really hard and making Swift UI even better. And for just playing around with it's really nice, and also prototyping things, it's really, really easy. So we can continue with our presentation. Okay, we covered it. So there's one theoretical thing that I would like to talk about, and this is automatic reference counting, because this is a huge difference how memory management works in iOS compared to, let's say, Android. Because on iOS, we are using automatic reference counting. And this is a very different approach to the garbage collection we are using on Android. The garbage collector basically works like this, that algorithms try to understand which objects are in memory and not used anymore to clean it up and free up memory. And on iOS, we kind of have to do it ourselves with automatic reference counting. So let's say we have these two classes as we had before, like the person. And this only applies to reference types. So the one which gets passed by reference, not the one which gets copied. Let's say you have two objects and they live side by side and they point to each other. So there's a person which has a connection to another person and the other way around. So once a person points to another, has a connection, like a reference to another person, the reference counter increases by 1. And what we have to take care here is to use, at least in one direction, a weak reference, because this doesn't increase the counter. And this is a bit like, it's very, very briefly, I don't go too much into detail because this is, especially in the beginning, very confusing, but it's a very important topic to understand, because if you don't take care of that, you have memory leaks and basically the app doesn't work efficient at all. It might crash because iOS, the iOS operating system decides, okay, your app is using too much memory, and it will just kill it. So it's like a crash for the user, which is a bad experience. But the fact that we are having automatic reference counting makes it even possible to use an iPhone, like the newest generation, with only 4 gigabytes of memory, which doesn't seem like a lot, but on iOS it is a lot, compared to, I don't know, one of the Android phones, the flagship phones with, I don't know, like the Galaxy S21 Ultra with 12 gigabytes of memory. You might think, okay, that's much more, but also because the garbage collector is not as efficient as automatic reference counting, you need much more because it requires much more memory per app. Okay, this we already built, our little banana app. And here we have one other thing that I would like to talk about. As I said in the beginning, you can build iOS apps, iPad apps, tvOS, and more. And with more, I'm talking about Linux, because Swift works also on Linux. There's a compiled version, or you can compile it yourself. And you can write real Swift applications, or applications in Swift with binaries and everything for Linux. There's just one downside. You might think, oh, cool. So then I don't need a macOS computer. I can just buy a cheap Windows laptop and install Linux in it and use my iOS apps there. But this is not how it works. Because while Swift works on Linux, the iOS SDK does not. So you need still macOS to build iOS apps, but you can build other software in Swift. For example, I built a side project where I used one of my old Raspberry Pis, and I built a lamp that I can control with like there's a little server running on it, and the entire code is 100% written in Swift and runs on this little Raspberry Pi and basically controls the app. And with some other things like a fake HomeKit system, it's possible to control the app, everything 100% in Swift with Siri and HomeKit. So that's something that I just built with Swift without running it on a Mac system. So you can, even if you just run Linux, you can still play a bit around. So we can have a little recap here. As I said, macOS is required. While Xcode itself is free, so if you have a Mac, you can it's for free to download Xcode and play around. You can even install it on your device and this kind of stuff. It's really fun and easy to use. I mean, you saw, I just started like 2 weeks ago with Swift UI and building this little application. Of course, I prepared it before I had this little live stream here, but it took me maybe like 20 minutes to build it. So I could have done it also in the live stream, but then, there are always errors coming up that you don't want to make people wait to look at you, how you figure it out. There's just one downside. In order to launch your app in the Apple App Store, you need to be part of the Apple Developer Program. You get some benefits from it, like also the certificate to push your app into the Apple App Store, or at least try it, because of course every app gets reviewed by Apple itself. Like there's at least one real human being involved in the process to click the button, okay, your app is approved or rejected. And this developer program costs $99 per year. But this is not per person, this is per team. So even if you say that you're building an app with a bunch of friends, you can buy this or pay this developer program, and you just share the costs. And that's basically it. I mean, if you want to keep in touch, send me a message privately. You can use my Twitter handle. It's Kevin Chromik. And I want to say thank you very much. And we can go now into the questions, if there's some questions there.
Thank you, Kevin. That was great. If we don't have any questions, I can ask you some.
Yeah, sure.
So I know you have a master project which you used Objective-C to build.
Yes.
Couldn't you use Swift? Wouldn't it be easier to use Swift?
Yes, it would be easier, but the problem is when I started the project, Swift didn't exist.
Oh,
because I started the project in 2013, the initial code. And yeah, Swift got introduced 1 year later. And of course, I mean, I had already a hard time to learn Objective-C, and I just wanted to get it done. So I had no intention back then to rewrite everything in Swift. And my actual first contact with Swift was in my first job. So when I applied in this company at Freeletics, the app back then was in Objective-C mainly, but then back then they decided every new code into the app of the app will be in Swift, because as I said, Swift and Objective-C can be both at the same in the same application. There are some limitations, but it works. And back then it was the first time that I got in touch with Swift, and most iOS developers say it's much more fun to use, especially now, because it evolved already quite a bit.
so your first interaction with Swift was like in your first job?
Exactly,
Didn't you learn a
2015.
little bit in college?
No, because in college there was basically no mobile development back then. They started to have the course just when I left, when I graduated, and basically it worked like this. I had to do like a software project, like a rather big one, for 1 semester, and this is back then it was at least mandatory for all information management students. And I went to a professor who was very much into video navigation and this kind of stuff. And I asked him if he has a cool project that I could work on for this semester. And then he gave me gave me such a couple of suggestions, and I chose to build the iPad application. He also said that's the most difficult one, but working it on a tablet, you can choose if you want to have it for iOS or for Android. And I was already back then a Mac user, an iPad user, so I said, why should I build it for a different platform? So I built it for my own platform, and this is how I got in touch. So I think now they are working on apps in university built in Swift, but maybe rather Android, because I think they can't force every student to get a Mac.
Yeah.
Yeah. So in my opinion, it's just a matter of taste. If you prefer Android, go for Android. If you prefer iOS, go for iOS. For me, it was just I was interested into iOS development, but there's really no it's really hard to say one thing is better than the other. It's just a matter of taste, like with most of things, I mean.
And I think you mentioned that you studied information management. What difference does it have than a traditional computer science?
It's basically a mix of economics and computer science. So they try to make it like 50-50. So 50% of the courses are, or let's say rather 40% is economics, 40% is stuff from computer science curriculum. But the other 20% are classes that they are specifically for that studies. So I also had to write in bachelor. I had to write 2 bachelor theses, one in economics and the other one in computer science. For master, there was only one, and I went more into computer science, of course, because this is what I enjoy more. But I also like the economic aspect.
That's great. So if we don't have any other questions, I think we can end the live stream.
Mm-hmm. Sure. And
thank you
very much.
Thank you. That was a great presentation, and I hope we would keep in touch.
Yeah, sure. Of course, as I said, if someone wants to learn more, just contact me on Twitter and drop me a message. And I'm very happy that I had the opportunity to speak here today.
Thank you.
Then thank you very much.
So have a nice day, guys.